the ones up, the tens, and the 100s places. So it's going to be like that, except we're going to line up x's with x's and y's with y's. Step 2, we will add or subtract the equations to eliminate one of the variables that has a common coefficient. So remember, the coefficient right here is the 2. It's the number in front of the x. And the way that we're going to be doing step 2 is to multiply either the top or bottom equation by a -1. And what this is going to do is change all the signs in that equation. And this is totally legal for me to do as long as I do it to every term in the equation. Step 3 will be to solve the equation for the remaining variable. Once I know the value of x or the value of y, then I will choose one of the two original equations and I'll substitute that value in so I can get the value of the other variable. And then remember that you always have to wrap up your two parts of your solution in parentheses where the x value comes first and the y value comes second. So we're going to do examples 1 and 2 together. And I just want you to add to the left of your paper this note, okay, that we have to be certain that we put the x's and the y's in the right place in the ordered pair, x comma y. All right, so let's go ahead and do example number 1 so that you can see what we're talking about here. In example number 1, I see that my x's and my y's are already lined up as well as my constant terms. And so what I'm going to do is choose an equation and I am going to multiply that equation by -1. And when I do that, it's going to change the sign of all of the parts of the equation. Now I am ready to just kind of subtract them like I would a normal number. So I have now y minus y is 0. 3x minus 1x is 2x, and 4 plus 2 is a positive 6. And now I have an equation with one variable, so I can go ahead and solve this. Subtract the 6's from both sides. -6 equals 2x. Divide both sides by positive 2, and my solution for x is -3. So that is the first part of my final answer. It'll be a x variable that's a -3. Now I need to find the y. So I'm going to choose an equation. Let's do the bottom equation. And I'm going to use the original. It was y equals x minus 2. Instead of having an x, I'm going to put a -3 in there because that was the value of x. And so I'm going to bring down the y equals and the -2. And so now I can simplify this. -3 minus 2 is -5. So my y variable I just found is -5. And so I'm going to go add that to my ordered pair. And that is my final answer, -3 comma -5. Let's do number 2 together the same way. I'm going to choose an equation and I'm going to change all the signs in the equation. I see that my x's, my y's, and my constants are already lined up. Both of these equations are in standard form. So I'm going to change the bottom one. Minus, that goes to a plus, and that becomes minus. Now let's combine these. X minus x is 0. 4y plus y is a positive 5y. And 13 minus 3 equals 10. So my last step, because I just have that 0, it's not really anything there, just divide both sides by 5, and y equals 2. So I know one part of my solution, which is the y variable. The y variable goes in the back. Now I'm going to choose an original equation. So let's do this bottom one again. I try to pick the equation that looks easier. Stick with the original. So what was it before I changed it? It was x minus y equals 3. I now know that the y variable is a 2, and I got that from right here. Don't forget to bring down the rest of the equation. X minus equals 3. And so now to get the x by itself, I need to add 2 to both sides. And now I can see that x equals 5. That is the second part of my final answer. The x value is 5, and that goes in the front. So that was fantastic. And this probably feels a lot easier to some people than the substitution method even did. What I'd like for you to do is pause the video and try to complete example number 3 and 4 on your own. All right, welcome back. I have completed numbers 3 and 4. You might want to pause the video just to check that you were able to do these correctly. But I do want to point out that even if you chose the bottom equations, you should still get the same value for the x or the y when you finish solving it in this second part here. All right. I'm going to go ahead and go on over to example number 5. And I have a note above here. Sometimes they're already lined up and the two of the coefficients are already inverses of each other. In this case, it is even easier. I do not have to multiply either of the equations by -1. I can just jump straight into solving, which makes it way simple. So 4x minus 4x is 0. 9y plus 7y is 16y, and 5 plus 11 is 16. So if I divide both sides by 16, I get y equals 1. And I am done with my first part of my solution. Now let's go find the second part of my solution. This time, I guess I'll choose the top equation. So 4x plus 9y, I'm going to plug a 1 in there, equals 5. So let's put that 1 in for the y. 9 times 1 is 9, so let's go ahead and subtract that. 5 minus 9 is -4 equals 4x. If I divide both sides by a +4, I get -1 for my x variable. So remember that because that's the x, that's going to go in the front. And I am finished. Why don't you pause the video and try examples 6 and 7? They're both just like number 5 was. All right, welcome back. I have completed both examples 6 and 7. And in number 7, I solved for the x. And I used the top equation, so I plugged it in where the x value went. Again, it doesn't matter which equation that you choose as long as you're using the original equation. Now we're going to do number 8 together, and then you're going to practice number 9. So in example number 8, the note that I have out to the left here is that we need to line these up. You can line them up however you would like. However, we need to get the x and the y both on the left side of the equation or on the right side of the equation. So what I'm going to do is I am going to take this top equation and I'm going to solve this and get x. I'm going to subtract the 3y so that it's over on the left. And so now I have x minus 3y equals 11. So I'm going to bring that right under here. X minus 3y equals 11. And then I notice that I have both of them are minus 3y or negative 3y. So I need to multiply. Let's just do this bottom equation by negative 1. So I change all the signs in just the bottom equation. And now what I'm going to do is subtract. So 2x minus x is 1x. Negative 3y plus 3y is 0, so that crosses out. And then 16 minus 11 is 5. So I now know the x variable of my solution. Now I'm ready to use an original equation and solve for the y variable. So I'm going to use the bottom equation. 2x minus 3y equals 16. I am going to plug this 5 in for the x. 2 times 5 minus 3y equals 16. This will give me 10. Subtract 10 from both sides. I have 6 equals negative 3y. 6 divided by negative 3 will give me negative 2. And so now I know the y value of my ordered pair, negative 2. And I'm finished. So notice that I had to do some work so that these x variables would line up, the y variables would line up, the equation or the equal sign would line up, and the coefficient would line up. Okay, everything has to be in perfect order. So I'd like for you to pause the video now and try example number 9 on your own. And it's just like number 8. You will need to line them up. All right, so I have completed practice problem number 9. Number 9 was just slightly easier than number 8 because when I rearranged my top equation, you can see that the negative 4y and then the positive 4y are already inverses of one another. So I didn't have to multiply anything by negative 1. All right, and now we're going to do some special cases together. Some special cases. So let's see what this looks like. I have a 3x minus 4y equals negative 10 and a 3x minus 4y equals negative 13. So I'm going to go ahead and I'm going to multiply the bottom equation by negative 1 so that all the signs will change for me. So that negative with that 13 will make it become positive. Okay, so now we can combine everything. 3x minus 3x is 0. Negative 4y plus 4y is also 0. Negative 10 plus 13 is 3. So if I just simplify that, I get 0 equals 3. And remember, I need to ask myself, is this a true statement or a false statement? Because now I'm in a situation where I have no more variables. It's just an equality statement. Does 0 equal 3? And the answer is no. This is not a true statement. So whenever we have not a true statement, we will have a no solution kind of situation, which would mean if I graphed these would look like parallel lines. So don't ever forget what that visualization looks like. So my answer is no solution. Now let's take a look at number 11. In number 11, I noticed that everything is not lined up. I've got my x variable on the top equation, it's on the left, and on the bottom equation, it's on the right. So I'm going to need to do a little bit of work here with this one. Let's subtract this 2x from both sides. And now I have negative 2x minus y equals 10. And so what I'm going to do is I'm just going to rewrite both of these equations right here. 2x plus y equals negative 10. Negative 2x plus y equals positive 10. And they're already inverse operations. I see 2x minus 2x, so I can eliminate something really easily. And that's going to give me a 0. And then, whoops, in my bottom equation, I had to subtract y right here. I just wrote it wrong, so that should be a negative y. So y minus y is also 0. Okay, and now I have a negative 10 plus 10, which is also 0. So I end up with 0 equals 0. And is this statement true or false? And it is very true. So this is infinite solutions. And if I were to graph these, they would be the same line, meaning that they touch everywhere. So my final answer is infinite solutions. Great job. So those special cases, we won't see them very often, but it is important that you know what to look for. If all of your variables end up disappearing on you, it's either going to be no solution or all solutions. Okay, so now if you flip your paper over, let's do the very last part, okay? What if there are no common coefficients? So if there are no common coefficients, we will have to multiply one or sometimes both of the equations by the same number to create a matching opposite, just like we had on the other side of the paper. So the numbers need to be the same, but the signs need to be opposites. Okay, so let's jump right in and look at example number 1. I see x plus 3y equals 6, and then I see 2x minus 7y equals negative 1. So what I'm going to do is I am going to multiply the top equation by negative 2. That would cause the x to be a 2x, and then I'm going to need the negative because it'll make it the opposite sign as the bottom one. So let's multiply all of our terms by negative 2. And then I'm going to write down here what I end up with, okay? Or here, let me write it right here. So negative 2x, negative 6y, and negative 12 is what I end up with. Now I'm just going to bring over the bottom equation. I'm not going to need to do anything with that. 2x minus 7y equals negative 1. So now I'm ready to put these together. Negative 2x plus 2x eliminates that. That's why it's called the elimination method. Negative 6y and negative 7y is negative 13y equals negative 13. So if I divide both sides by negative 13, I'll get a positive 1. So my y value is a positive 1. And now what I'm going to do is go back to an original equation, okay? The original equation that I'm going to choose to use is x plus 3y equals 6. That was that top equation before I made any changes to it. And so let me circle. It's this top equation that I'm using right here. And now what I'm going to do is I'm going to plug the 1 in for the y. So that's going to become a 1. And now I have x plus 3 times 1 equals 6. 3 times 1 is 3, so let's subtract that from both sides. And x will equal 3. So now I know my x variable. Now, when I come over here to write my final answer, remember, the x has to come first, the y has to come second. All right, so I know that sometimes students really do struggle with this. They ask me all the time, how did you know which equation to multiply something by, and how did you choose which number to multiply it by? Okay, so let's look at the next question or the next problem, and I'm going to kind of talk out loud through my thought process, okay? So I see this 9x in this 2x. And in order to make those be matching opposites, I would have to multiply them both by something. So I don't want to do the x's. So let's not focus on the x's. Let's look at the y's and see if that would be easier. So on the top, I see a positive 3y, and on the bottom, I have a y. So what could I multiply that y by to make the sign be opposite and the number be the same? And so I know if this is a positive, that has to be negative, and then I need the number to be the same, so 3. So that's how I'm choosing. I'm choosing to do the y's for this reason. And then how do I know which equation I have to multiply by the negative 3? Well, it is the equation that needs to be changed. That y is what I had to change. So I now know I need to multiply the bottom equation. Okay, so I'm going to erase these notes here in this explanation real quick. And let's go ahead and multiply our bottom equation by negative 3 on all of my terms. Okay, I'm going to come over here and I'm going to rewrite the top equation with no changes. 9x plus 3y equals 12. And now I'm going to rewrite the bottom equation after I multiply. So negative 3 times 2x is negative 6x. Negative 3 times y is negative 3y. And negative 3 times 5 is negative 15. And now I am ready to simplify these. So the y's are going to cancel because that's what I wanted them to do. 9x minus 6x is 3x. 12 minus 15 is negative 3. So if I divide both sides by 3, I now know that x is a negative 1. Alrighty. And now I'm ready for the second part. I need to choose an original equation. So in this one, I want to do the bottom equation because the y is already by itself there. So let's do 2x plus y equals 5, where I need to plug in the negative 1 here. So 2 times negative 1 is negative 2, and then add 2 to both sides. So now I know that the y equals 7. And so now I know the y variable of my solution as well. So my answer is negative 1 comma 7, and wrap those up in parentheses. So I will I'll try to leave examples 1 and 2 up here so that you can see them. I want you to try examples 3 and 4. And then at the bottom, we're going to do number 5 together. So here's 1 and 2. I want you to work on 3 and 4. I have completed practice examples 3 and 4. Go ahead, pause the video if you need to take a look at my work. I know that in especially number 4, you had different options. You could have multiplied the top equation by a -5 and eliminated the x variables instead of the y variables. But your final solution should have still come out to be -8, 5. All right. Now what we're going to do is number 5 together. So in number 5, what we're going to do is we're going to eliminate, we're going to just multiply the bottom equation. So you don't always have to eliminate the first variable. You can do the second one, and this will kind of be our last little practice one together. So I see the -3y and then the -y right here. So the only thing that's missing is, let's see, I need this to be positive, and so a negative and a negative will give me a positive, and then I need the number to be 3. So I'm going to multiply all 3 parts by -3. Okay, so let's go ahead and just finish solving this like we did the other ones. Bring this over, and then -3 times 2, -3 times -y is +3. -5 times -3 is a +15. So I'm going to start to simplify. Divide by -3, and x equals -4. And then let's just pick an equation to plug that into. It doesn't matter which one. This time I'm going to use the bottom equation. 2x minus y equals -5. And I need to plug in the -4 for that x. All right, so that gives me a -8. So I'm going to add 8 to both sides. So add 8. -y equals 3, so y will equal -3. Had to divide both sides by a -1. All right, and so there's my answer. I'm going to write it right here. X is -4, y is -3. Great job. So your classwork assignment is to complete these 10 practice problems. It is a review of all the 3 different methods that we've learned when it comes to solving a systems of equations. 1 and 2 are both the graphing method, 3 through 6 are substitution, and 7 through 10 are elimination. You do need to follow the instructions and do the type that you're being asked to do in each area. This will be a part of your notebook grade at the end of this quarter, so please be sure that you've gotten it done. We will do this with a partner, all right? So as soon as you're done with your notes, find somebody else who is also completed with their notes and work on this together before you begin your practice assignment that's posted onto Google Classroom. Until next time.